Hey folks, let's take a look at how to compare and order rational numbers. So essentially, what we need to do is compare fractions, possibly compare decimals and that sort of thing. So how can we compare fractions? This is one method. How about if we change the denominators to be the same number? And then we can compare the numerators and see which one is bigger. And that, the comparing of those numerators, that would literally be able to say, hey, the left fraction is bigger or the right fraction is bigger. I always like to take my fractions and put them apart over here with a little bit of space so we can work on it. And then I start asking myself, what can I change these denominators into, right? The 9 and the 12. What could I multiply them by to change them into the same number? Well, I quickly realized that I could times this by 4 and make this 36, and I could times this by 3 and make that 36. That gives us the same denominator for each of the fractions. We're making equivalent fractions. So 4/9 is going to be equal to this fraction right here. But since we times the bottom by 4, then we need to times the top of the fraction by 4, the numerator. And then we come over to the 5/12 fraction, and we times the numerator by 3 because we times the denominator by 3. So again, now that we have common denominators, excuse me, the 36 right there, come back and compare your numerators, the 16 and the 15. Which one's bigger? The 16/36. So if we come back here and we say, well, what does this represent? It represents the 4/9. We would say that the 4/9, this one, is the larger fraction. Now that's one method of doing this. Another method is simply changing the fractions into decimals and then comparing your decimals, right? So you can go back and look at my previous video about how to do this, but I will briefly show you how we do it. You have to take the numerator and place it inside of the division box. Then you take the denominator and place that on the outside of the division box. And then you just go into your normal routine. Can 10 go into 7? No. Add the decimal, pop it upstairs, hang an extra 0 if you need it. Pretend that you don't see this decimal right here, so can 10 go into 70? Yes. So 10 times 7 is 70. We subtract the 70, there's nothing left over. And so that tells me that 7/10 is 0.7. So we have 0.7 here. You can go ahead and make that 0.7. So we've now turned 7/10 into, yes, it's pronounced 7/10 also. The 12/17 is a little bit more of a challenge, and I'll have this to show you. Again, the numerator goes inside of the division box, the denominator goes outside. Add the decimal, and this is where your frustration usually starts. Can 17 go into 120? I'm going to help you out. It goes in 7 times. There's 1 left over, and because there's something left over, just add another 0 and bring it down. In this particular case, 17 cannot go into the 10. So we're just going to put a 0 right here to say, hey, 17 can't go into 10. But we still have something left over, so how about we add another 0 and bring it down? And here we have 17 being able to go into 100 5 times. So 17 minus 5 is 85. We have 15 left over. And it's going to keep going, but look, we've got 3 digits right here, and we can go one more to round it if we need to, but at this time we're just trying to compare these 2 decimals, okay? And I realize that whether we go through and we go to another number to see if this stays a 5 or rounds up to a 6, I realize that I can compare these 2 decimals right now. This is 0.705. This is only 0.7. So since this has 3 digits after the decimal, how about we add 2 zeros right here? And what we're trying to get you to see is that you would kind of do this. What's bigger, 700 or 705? I'm hoping you say 705. So which fraction is larger, 7/10 or 12/17? Since it's this for the decimal, we're going to say this fraction is the largest. So that's another method. And by the way, there are still other methods out there. Find one that works for you that you can use quickly and efficiently to compare fractions.